Okay, good morning everybody, and welcome to this session about space transportation. So I'm Thomas Penoso, and I will walk you through this presentation, which is roughly about 2 hours, and it will drive you through the different steps, and it's about space transportation. So as we are going to see in the summary, first of all, I'm going to give you a brief description of the European launch vehicles. So the different way that Europe has to get to space. Then I want to walk you through the mission analysis process. So we're going from theory up to the reality. So we see how you really do the things. And then at the end of the presentation, we're going to get through some pictures and video from actual real launch campaign in French Guiana, where all the European launchers are launched to space. So I'll try to be as clear as possible, and let's go. I think now we can skip to the real launch campaign. So I would say that this is the part, the theoretical part that we have done so far. So now you know what is a launcher trajectory, what are the constraints that you have to take in account, what are the typical parameters that you must survey, the telemetry, the visibility. And what we want to describe now is, I'm going to do is a real launch campaign. So I'm going to tell you, after this theoretical part, how things really happen on the ground, okay? So when you do this work, when you work at the European Space Agency or any other in Ariane Space, CNES, or the CSG, what is the real launch campaign, what you're going to see. And this is the important stuff. Okay, so first of all, the logistic. Okay, so how I think you have noticed throughout the presentation that the launch site, I mean the European spaceport, is in French Guiana, but all the elements of the launcher are produced in Europe. Okay, so there is an important part of logistic which is due to the fact that the launcher parts are not produced in one single site, but they come from all over Europe, because Ariane 5 is a European project. And so basically this map tells you exactly which piece come from where, okay? So at the very beginning, what you have is that you have a boat going from Marseille to Livorno, where the 3 segments of the solid rocket booster are put on board the boat. They are produced in Colleferro, near Rome. And by truck or by train they can get to Livorno, and they are put on the boat, okay? After they are put on board, what happens is that the main cryogenic core, the EPC, is produced in Les Mureaux, near Paris, which is a very cute city along the Seine River. And when this stage is produced, it's going to put on a board, which go to the Le Havre harbor in the north of France. Then the boat that has just taken the segment on board is going through sea to Le Havre, and then the EPC is put on board. Then at the same time, in parallel, the fairing, which is produced in Switzerland, is going to the Rotterdam harbor, and in that moment then the boat after Le Havre goes to Rotterdam to take the fairing, and then in parallel the boat after Rotterdam go to Bremen. And obviously there is no harbor in Bremen, but the upper stage is produced at Astrium Airbus Defence and Systems facilities in Bremen, and then is put inside the boat. And at that moment the boat leaves from that part of Germany up to Kourou, down to Kourou. It takes roughly 15 days. And the boat arrives in Kourou with all the elements on the launcher, each inside its container. And once it gets in Kourou, it gets constructed. And then we are going to see it right now exactly how it's going to happen. This is the Toucan arrival. So the Toucan is the boat, okay? The boat is a mid-sized boat with all the elements of the launcher inside, arriving at the harbor in French Guiana. All the different stages are unloaded from the boat, and there are road transfer to the CSG, so which is the European spaceport. What you see here is first is the EPC, is the big truck. So you see this is the launcher stage, and on the right side you have the fairing, and the upper stage. I would say in parallel of the launch vehicle arrival, there is the spacecraft arrival. So spacecraft manufacturers are spread all around the world, from Japan, India, China, Europe, and North America. And there are different constructors, and depending who is obviously the customer, as there is gonna normally is issuing some invitation to tender, and then is gonna choose after a bidding process who is the satellite manufacturer. It takes roughly about 3 years, and after the satellite is completed, it is transferred by Antonov to French Guiana. So this is, for example, the arrival of a certain spacecraft with a special plane, which in its belly contains the spacecraft container. In parallel, so the satellite and the launcher live 2 lives apart, okay? Until the moment in which the satellite is put on the launcher. But until the moment, they live 2 lives apart. And this is the arrival of the upper stage at the BIL, which is the integration building, Ariane 5 integration building. So what you see is a man opening the door of the building to allow the upper stage to be unloaded, and what you see there is the nozzle of the upper stage. At the same time, so the cryogenic stage arrives in the main building, is taken out by this container, and is going to be erected. So what you see here is the operation that we call hissage, in which the stages which arrive in a horizontal position, they are put vertical. So the upper stage on the left part of the screen and the right stage on the right part. At the same time, the solid rocket booster, which have been, so the different segment, if you remember, I told you the segment are arriving from Italy. They have arrived in Kourou, and they have been assembled in one solid rocket booster. And the solid rocket booster, which is assembled in a very special building because it's solid propellant, so it's very dangerous material, is then through rails is going to arrive to the integration building, okay, and is going to be linked and connected with the main cryogenic core. And now you see on the right part that the launcher is taking shape, like in its final part. Once the 2 solid rocket booster has been connected and assembled with the main cryogenic core, then the Ariane 5 is moved from the BIL building to the BAF building. The BAF building is the building where it is going to receive the satellite and the fairing. So there is this movement through rail from the BIL building to the BAF building. And then there is the encapsulation sequence. This is exactly the moment in which the launcher has done one part and is going to meet the satellite, which has done its life. So now, just keep in mind that you have a launcher assembled and waiting for the satellite to be put on board. Now what we are going to see is what happened to the satellite that arrived with the airplane I showed you before. So the container has been unloaded from the Antonov, okay, and has been brought to the EPCU, which is the satellite processing facility. So as you know, all the satellite hardware must be processed in a cleanliness condition, which is very specific. And the facility that we have in Kourou for satellite processing give you 100,000 particles per million cleanliness threshold. So the container is open, as you see here, and the satellite is taken out and put in an horizontal position. For roughly about 2 weeks, there are all the health checks. So the satellite manufacturer teams, they check that the satellite is completely in perfect shape, is working, there is no problem. And after all the electrical checks are done, then you proceed to filling of the spacecraft, because you know that the spacecraft contains hydrazine, not only to perform the apogee boost, which I was telling you before, but also because during the 15 years of life, the satellite is maneuvering through attitude control system, so it has a few hundreds of propellant on board, which allow it to control not the position, but the attitude for the 15 years of life. So the filling of operation are quite dangerous, because hydrazine is a dangerous propellant. I mean, if you breathe it, if you touch it, it's not a nice substance to be next to. So you have propellant people that wearing this, I would say, space suit to fill in the propellant inside. When the satellite is filled, then is put on the adapter. So you can see here the satellite is put on its adapter, and is also linked to the separation system, because as I told you before, on the adapter there is the springs that will be compressed, and when into orbit they will push the satellite for separation. After the satellite has been assembled on the adapter, it's going to put on the SILDA, which is this double launch structure. So as you see here, the satellite arriving in the same building as the launcher and is assembled over the SILDA. In parallel, there is the assembly of the lower spacecraft. So the lower spacecraft, when I say upper spacecraft and lower spacecraft, I'm distinguishing them in base of the position they have on the launcher. So the upper satellite is the one sitting on top of the SILDA, and then you have the lower satellite. The two satellites are processed at the same time, okay? So by different teams, because often they belong to two different manufacturers. So you have upper satellite, lower satellite, and launcher, which lead three different lights in parallel until they meet. This is the moment in which the lower spacecraft is integrated on the launch vehicle. So you see the white part is the launch vehicle, and that is the spacecraft. And the last operation, which is a pretty full day at CSG, is what we call integration of launch vehicle upper part. So the fairing is put on the upper satellite and on SILDA. And then when all of this has been assembled, the launcher moves to the launch pad. So this is at J0-1, so 1 day before the launch. The launcher assembled with the satellite inside is moved to the launch pad and ready for the final chronology. What you have to know is that during this process, the satellite have electrical link through the mast to the offices of the customer, who can monitor the behavior and the status of their satellite basically 24/7 before launch. Okay, so they are encapsulated, protected. Some parameters are monitored by the ground team. Okay, and then we arrive to the J0, which is, I would say, the day of 3 years of achievement in which the satellite manufacturer has built the satellite, the launcher has been built, the trajectory has been made, and here is the launch, so the day of the launch. And I want to walk you through what are the main steps of the final chronology before launch. So the launch here was at 17:56 hours, so almost 6 in the evening local time, and the beginning of the activities start at 5 in the morning. So just to give you an idea, it's around 12 hours final chronology to launch the rockets. So 5 in the morning, you have the official beginning of the final chronology. If you see 6:30 in the morning, SRI switch on. So you switch on all the inertial platform inertial measurement unit. Then you go through the control loops. You control all the loops are switched on. You pressurize the GAT and the GAM, which are two hydraulic systems to put in place the thrust control for the booster and for the main engine. Okay. You do the IMU alignment and control, so you align the inertial measurement unit. Before start filling the stage, what you do is you flush them with nitrogen and helium. So you flush the EPC lines, you switch on the onboard computer, and you start at 6 hours before launch, you start filling the stages with the propellant. So since the propellant is liquid hydrogen and liquid oxygen, you start filling the launcher. It takes a few hours to launch. And what you need to do, you need to keep topping up, because the propellant is minus 200 degrees and is liquid. So it keeps on evaporating, okay? This is why you need to feed the launcher tanks just until few seconds before launch. In the movie I'm gonna see there's gonna be like these arms which retract, and this is the end of the filling, okay? In parallel, there are some weather reports that tell you if the weather is gonna be okay for the launch. Then I will say you have the filling up of the tanks. You switch on the transponder, the transmitter, and then 1 hour before launch, you have at 1702 and 1712, we have three very important steps in which you say fluid system ready, electric system ready, and system ready. Okay, so basically you have the fluid part, the electric part, and all the system part. Once these three parts are ready for launch, then you have the beginning of the synchronized sequence. Okay, the synchronized sequence is an automatic sequence in which there is no human control, and in which the management of the launch pass from the ground to the launcher itself. So the launcher itself, like for example, the energy is taken off, so the battery of the launcher are starting to give energy for the management of the launcher, and the launcher become more and more independent, okay? And then at H0, so the moment of takeoff, you have the ignition of the Vulcain tune engine, and then all the procedure that I told you before. Okay, so I'm gonna leave you with some couple of movies that I think you're gonna enjoy. They will walk you through what is a launch campaign in French Guiana, and they will show you with the pictures and with the image what I've been telling in these last 2 hours of lesson. And that's it. So I hope that it was somehow useful what I told you this morning, that it was interesting. I hope that the image will make you feel the same emotion that I have every time I see a launch. And just remember that if you happen to go to French Guiana for travel, you can visit the European spaceport. You can, there are visits, you can see the launcher, you can see the launch, you can visit all the infrastructure I've been telling you about. So that being said, I'm done. And again, thank you for your attention and have a good day. Bye-bye.
3, 2, 1, top. Allumage Vulcain. Allumage AP, décollage.